Hello and welcome to the Titus Timeout Podcast. I'm Jenny Abney-Civi and today we're going to discuss the perimeter heating challenge. Cooling and heating the perimeter of a building has always been a challenge, specifically where to put the air during cooling and heating. So let's draw a perimeter of a building. Say this is the perimeter wall and there's a slot diffuser up here. So when you're in cooling, you want the air to come like this. You want it to go across the ceiling and roll the space before it gets into the occupied zone. In heating mode, you want the warm air to go down the glass so that it gets into the occupied space to warm the zone. If your diffuser is always set in cooling mode, then when you have warm air, it'll go across the ceiling, but throwing warm air across the ceiling up here means it'll never get mixed into the space and you'll waste energy. Now if you set it in the heating position so the air is always blowing down, when you're getting cold air though, you're going to be throwing this cold air into the occupied zone and people are going to feel drafts or be cold. So the most common solution is actually a compromise where you set one slot of the diffuser to throw across the ceiling and one slot to throw down the glass. This way you have half the air going where it needs to go at all times. We call this the 50-50 compromise. The problem is that you also have half the air going to the wrong place at all times. So this may be reasonably acceptable in cooling to have the cold air going down the glass into the occupied zone. People may just put on sweaters or something. But during heating, this wastes energy because half the air that you paid to heat up will never reach the occupied zone. Now many slot diffusers are adjustable, so the building owner or facility manager can move the pattern controller from cooling to heating position in the fall and then back to cooling in the spring. Let's face it, this probably doesn't happen in a lot of places. So wouldn't it be great to have a slot diffuser change positions by itself? Well, that's exactly what auto changeover diffusers do. They change the position when the supply air changes temperature. Titus makes a couple auto changeover diffusers. They all do basically the same thing, which is switch the airflow pattern from cooling position to heating position when they sense a change in the supply air temperature. The diffuser was our first auto changeover slot diffuser. It uses a bimetal alloy that changes position at 62 degrees and 82 degrees Fahrenheit. So when the diffuser sees 62 degrees supply air temperature, it puts the diffuser into cooling position and directs the air across the ceiling, and in 82 degrees it puts it in heating position and directs the air down the glass. Let's make a little room up here. There are a couple ways to actuate the pattern controllers in an auto changeover slot diffuser. You can also use a thermal wax pill or a temperature sensitive metal spring, but we chose the bimetal alloy because it allowed us to make it a true two-position device. So here's what I mean by that. If you use a thermal wax pill or temperature sensitive spring, the wax or spring expands and contracts as the temperature changes. So let's look what that would look like in a space. So let's draw a perimeter again with our slot diffuser here. So at 60 degrees it may be in the fully cooling position, and at 80 degrees it might be in the full heating position, but as it moves between the two, it'll kind of sweep through the room. But when it has 70 degrees supply temperature, it could be directing it at a 45-degree angle into the space and directly at an occupant in the space. So let's move him up into the corner now. The bimetal alloy that the diffuser uses snaps between the heating and cooling positions. So if the supply air temperature is 55 degrees, the unit will snap to the cooling position and stay there until it sees 82 degrees. Then it'll snap to the heating position and stay there until the supply air drops below 62 degrees again. So why is this two-position actuation important? If you have your slot diffuser connected to a fan-powered terminal unit, and if you recall from the fan box podcast, the first stage of heating for a fan box is mixing plenum air with the primary air. So you could have supply air temperatures in the mid-70s quite often with a fan box. If the diffuser wasn't a two-position device, it could spend a lot of time in that middle range directing the air at a 45-degree angle into the space and towards the occupant. Titus also makes an auto changeover slot diffuser that has more controllability called the EOS. The EOS has a small control board that allows you to use dip switches to set the heating and cooling set points. The set points can be set anywhere between 69 and 73 degrees for cooling and 76 to 80 degrees for heating. And one of the coolest things about the EOS is that it is solar powered. It actually harvests energy from the space lighting to provide the power for the control board. There's a great video that explains the EOS operation on our YouTube channel. I'll put a link down in the description below. We run tests with perimeter diffusers set up in the 50-50 compromise position I discussed at the beginning of the podcast and compared how quickly a room got up to set point during heating. What we found is this: if you draw this and temperatures go up here and time goes across the bottom, if you started at 68 degrees, after an hour the 50-50 compromise setup was only at about 70 degrees, whereas the auto changeover setup was at 74 degrees after an hour. The difference between these two lines is basically the energy savings of having the air go into the correct position all the time. So that's an overview of perimeter heating and auto changeover diffusers. Don't forget to subscribe to our YouTube channel, and thanks for taking the time out with us.